So what is this? Transformations part 4, I think. I think this would be the 4th part of the notes. I think so. Just practicing today. So what we have here is a question where we're going to transform a function. Now, we've done these a few times. The difference is all the times we've been transforming functions, I've asked you to do one transformation, just one. And we've usually done it to a parent function. And sometimes we change the function a little bit. This one says, let the graph of g be a vertical shrink by a factor of 0.25, followed by, which means you have to do it in their order, a translation 3 units up of the graph. F of x equals absolute value of x plus 8. And then write a rule for g. When I say a rule, I mean an F rule. We're writing an F rule. It says vertical. So class, vertical. Is this up and down or left and right? Up and down. So if it's up and down, class, is this changing the x's or the y's? The y's. Good. Is that going to be inside or outside? Outside. So for the very first thing where it says a vertical shrink, we know that it is going to be outside of this. When it says shrink, I need to know the operation. Is it adding, subtracting? Is it negative sign? Or is it multiplication? See, we've learned 3 different transformation operations. There was adding and subtracting. And since we're talking about outside, so there's adding and subtracting outside. There's a negative sign outside. Or there's multiplying by a number on the outside. Which one is it? Since it says shrink. We're multiplying. We're going to be multiplying by a number. That means we're putting a number on the front. It says a vertical shrink of factor 0.25. I'm going to make that a fraction. I don't want to say 0.25. I want to say 1/4. It's the same thing. Y changes. Did he do the same or the opposite? Okay, class, same or opposite for y changes? Same. So you've already told me we're multiplying on the front, and you say same. So that means I need a excuse me. I need a 1/4 on the front. That is a vertical shrink of factor 1/4 or factor 0.25. Then it says followed by a translation 3 units up. Well, we've already talked about up and down. Up and down is a y change, which is outside. This one says translate. So what operation is that? Is it add, subtract? Is it negative? Or is it multiply? Which one is translate? Come on, guys. Is it add, subtract as a class? Is it add, subtract, negative, or multiply? See, what scares me is that nobody's answering. He doesn't have his notes out. That cell phone was super addictive. Translation is add, subtract. I'm telling you guys, it's going to be so scary if we don't start activating our brains before we get to math class, okay? I could tell you everything. I could talk at you guys constantly and just dictate the entire time, but you won't learn that way. I'm telling you, you won't. It just won't work. Translations, shifting, is always adding or subtracting somewhere. Because it says translating up, you're changing your y values, which means you're outside. Outside changes are always going to do the same. So up is going to be addition like we expect it to be. Like that. Now, that is the rule for G. This one function notation rule says vertical shrink, factor 1/4, and then up 3. So you're looking at this 1/4 fx plus 3, and you're asking yourself, how would you know that the shrink comes first and the shift comes after? How would you know? Would anybody, and I'll look for a volunteer because asking my class to talk to me clearly doesn't work. Would anybody like to take a stab, and it's okay to be wrong, just take a stab at how you would know that the shrinking had to come first? What do you think, Nevaeh? And she says because it's multiplication, so what are you getting at? Why would you do the multiplication first? Right? You do have to multiply the other side. You're there. You're right. It is the multiplication first, but why multiplication first? Something very algebra 1-ish. I'll get you there. Your two operations are multiplication and addition. Why multiplication first? According to what? You know it. You know it. You know why. You're just struggling with the word.
It's PEMDAS.
PEMDAS. There you go. I mean, you knew. I could see it on your face. You clearly knew. Yeah. It's the order of operations. You outside stuff does exactly the same thing that you would expect. So if I give you two outside operations, you follow the order of operations. You follow PEMDAS. The multiplication happens first, and then the addition happens. So what we're going to do is, since I've written the rule, I'm now going to apply the rule, but I'm going to do it in two different steps. I'm going to do the multiplication first, like Nevaeh said, and then after I've done that, I'll add the 3. Let's see, how do I want to do this? So we're going to take our f of x, and we're going to slap a 1/4 on the front. On the other side, we have absolute value of x plus 8. We have to apply this part of the rule first. So if we multiply the left side by 1/4, we multiply the right side by 1/4. And the only way you get the whole right side is if you use parentheses and distribute the 1/4 to the outside. That means the front of the absolute value bars, yes, there's a number there, it's a 1, and to the 8. So that is going to give you 1/4 absolute value of x. And instead of saying 1/4 times 8, why don't you say 1/4 of 8? Which is just 2. And at this point, we would have to add 3 to finish it up. And the plus 3 is now the new thing. That's why I changed its color. If I add 3 on the left of the equal sign, I had better add 3 on the right of the equal sign. We were told to call that G. So it's going to give us 1/4 absolute x plus 5. And if you were to graph that one that I wrote in blue and the original f of x, it would be 1/4 as tall, and it would have been shifted up 5. Order of transformations matters. Outside things do exactly the same thing we think they should, so they follow the order of operations. Follow PEMDAS when you're doing transformations of the outside. Cool beans? All right. Now we are going to translate 6 units down, followed by a reflection over the x-axis. Order matters. Order matters. We were told that we have to shift down first and then reflect over the x-axis. Now the problem is reflecting is technically a multiplication. So if I just wrote the rule that had both changes on it, you would have to do the multiplication first. So this one gets a little bit trickier for writing the rule for h. Rather than writing a function notation rule, I'm just going to apply the two transformations that I see one at a time, and I'll just end up with an h of x at the end. All right? And that's because we're going to be doing these transformations outside of the order of operations. Or you know what, I could even make it a better question if you wanted. Can make it a better question. Yeah, you know what, I think I'm gonna change it. Instead of down, how about we give it a direction? Let's go a direction that's not up and down. Let's go, I don't know, let's go to the right. I like this question better. Let's go 6 units right and reflect over the x-axis. Yeah, I like this one better. If I'm moving left and right, am I changing my x's or my y's? X's. What about reflecting over the x-axis? If I'm reflecting over the x-axis, which is this one, am I moving left and right or up and down? And up and down, which means I'm changing my y's. So I have one transformation that changes the x's, and the other transformation changes the y's. Now remember, I told you there's not a single transformation, not a single one transformation that can change both the x's and the y's at the same time. So if I have one changing the x's and the other changing the y's, does it matter the order that I do them in? Imagine, remember when I gave you the points, a point tree, and I said transform the point tree, and you performed one transformation, and it changed either the x's or it changed the y's? Well, if you had one change in the x's and one change in the y's, would it have mattered what order you did them in? Well, no, it doesn't. You see, as long as one is an x and one is a y, it doesn't matter what order I told you to do it in. It's kind of like drawing a square. You don't need to draw this. But let's say I told someone to go, or even a rectangle. I told someone to go right 3 and then down 2. And they ended here. But couldn't you have gone down 2 and then right 3 and gotten to the exact same spot? You see, when you're changing your x's and your y's, it doesn't matter what order you do it in. Either way, you're going to end up in the same spot. There we go. I don't know why it didn't work the first time. So let's write our rule. It says 6 units to the right. You guys have already told me moving left and right is changing the x's. So class, is that going to be on the inside or the outside? Heard a mixed bag. If I'm moving left and right, I'm changing my x's, inside or outside? Inside. X's are always on the inside. It says shifting, translating, whatever you want to say. I need to know the operation. Is this adding and subtracting? Is it negative sign? Is it multiplication? Shifting is which one? Would it be adding, subtract? Would it be add, subtract? Would it be -1? Would it be multiply? Adding, subtract. So I know the x has to get written first because we just said we're adding and subtracting. That always happens after something. It's inside change. So is it going to give me the same or the opposite? Opposite. So if it says 6 to the right, what would I expect to see after my x? A -6 or -6. I heard both answers, but they mean the same thing. And then it says followed by a reflection over the x-axis. But guess what? Who cares what order? If guys, you've already told me if I go over this x-axis, I'm moving up and down, which means I'm changing my y's. So is that change inside or outside? Outside. Now I have an outside change. It says reflect. Is that add, subtract, negative, or multiply? Negative. Somebody knows. And we've already said it's outside, so just put a negative sign on the outside. Now the beauty of this rule that we've just written right here is that it doesn't matter, like I said, what order you do it in. So you can actually do it all at one time. You don't need to do it at a separate time. If you'd like to separate the two, go for it. It won't change your answer. I'm going to go ahead and do both. And I will even color code it. So I'll do the negative stuff in red, and I'll do the inside stuff in blue. We have a negative sign on the front. So you better have a negative sign on the front. The only way you can capture the entire side, though, is with a set of parentheses. Now the function was 2 absolute. I used to have an x here, and then plus 5. And where I used to have an x, I opened a set of parentheses, and I will fill those parentheses with x plus 6. Outside changes can only change outside things. So that negative sign that I just put on the front can only affect the outside stuff. That negative sign can affect this 2. It can affect this 5. we're going to call this h of x. The 2 has become negative. Inside, well, the parentheses didn't really do much, so we'll just do that. And then the 5 has also become negative. There it is. There's a reason why I teach transformation so slowly. There's a reason why I spread it out and have all the practice days. It's because it's not very straightforward concept. It's something that students see very abstractly. So I'm just, like I said, I'm just needing you guys to ask me questions, help me out, talk to me when I ask you questions. Otherwise, I have no idea if my students are getting it or not. All right, I guess everyone's getting it. No one's saying anything, so we'll just move on. So how am I supposed to remember all of this crap, right? How am I supposed to remember it all? Well, I present to you the word Hyovas. It's a lot like PEMDAS. It's not a real word, but it's one that will help you remember how transformations work. You'll notice that the H is capital and the V is capital. That's because they stand for horizontal changes and vertical changes. So H, horizontal changes, V, vertical changes. The second letter describes where these changes occur. Where do horizontal changes happen? What do you think the I stands for? Inside. Horizontal's X changes, and horizontal changes happen on the inside. So if horizontal changes happen on the inside, where do vertical changes occur? Outside. And then we have our O and our S. Our O and our S describe how the transformations behave. See, horizontal changes, inside changes always do the opposite. So they have an opposite effect of what we were thinking, while our outside changes have the same effect that we were thinking. Meaning, if I said stretch, the number on the front should be bigger than 1. If I say shift up, I would expect a plus on the outside, things like that. So Hyovas is basically my script. Is that changing x's or y's? Is it inside or outside? Is that the same effect or the opposite effect? It's my script, Hyovas. Has anybody heard of Hyovas before? None of you? Okay. Just curious. Did anybody take Algebra 1 at VMS? You did. But you didn't hear Hyovas? Who was your teacher? Do you remember? Miss Nell, yeah. Just out of curiosity, you a sophomore or a junior? Sophomore. She might have said Hyovas to you. I was just curious. As I taught it to my wife. And my wife teaches at Venice Middle. And she went and taught it to the math department there. And they loved it. So now they use it for Algebra 1 when they're teaching transformations. So I was just curious. All right, we have one more slide. Everybody's cool on Hyovas? Hyovas is your friend. It is the entire script. And here we just have 4 questions. Basically, it's a lot like your homework from part 2. Remember, homework number 5 was a 2-part homework. So you had 5 questions to do last night on page 17. And you have 5 more questions to do tonight on page 17. Together, they make one assignment, 10 questions. And page 17, I put a picture of page 17 in the course materials. It just says homework number 5 textbook page or something like that. So these 5 questions, we are going to write a function according to the rule. So it's going to write a function. I'm not too worried about what's the F rule going to look like. Don't worry too much about that. The job here is just tell me what the new function is. That's the job. Let's get the new function. So I've numbered them. I mean, they're numbered. I stole these from a textbook. I don't know, maybe you can tell because the white boxes around them. 5, 6, 7, 8. So number 5 says f of x is a straight line for x plus 2. our job is to get a horizontal stretch of factor 2. Well. Horizontal stretch, factor 2. So 5. Let's see if we can use Hayovas. Horizontal change. It says so. Well, first of all, is that an X change or a Y change, class? X change. Okay. X change is happening on the inside or the outside? Inside. Okay, so we know we're going to have to do something on the inside. I need to know the operation, though. That's not part of Hayovas, but I need to know what operation we're talking about. So we're talking about a stretch. I need to know if that's add, subtract, negative, or multiply. And only one person's talking to me. If I say stretch or shrink, is this add, subtract, negative sign, or multiply? A couple people said multiply. It's multiply. Shifting is adding, subtracting. Reflecting is a negative sign. Stretching or shrinking is you multiplying. So I know there's going to be a number sitting in front of my x. Last part of the script, same or opposite? Opposite. So if I said factor of 2, and remember, I'm not looking for the opposite number, I'm looking for the opposite effect. What number would I see in front of my x? Well, it needs to be the opposite. Well, remember, negative signs mean reflect. I'm not looking for the opposite number, I'm looking for the opposite effect. Instead of multiplying by 2, I'm going to, what would be the opposite of multiply by 2? Divide by 2. So, fraction. We use the reciprocal. That's how you're going to get the opposite effect. You use the reciprocal. So for horizontal stretch and shrink, we need to use our reciprocal. What we've been told to do is stick a 1/2 x everywhere we had an x in number 5. So we go 4, set of parentheses where there used to be an x, and then plus 2. And inside those parentheses is where we drop our 1/2 x. And we've been told to call this one, it's g. So this gives us the result of g of x is. Instead of saying 4 times 1/2, why don't you say 1/2 of 4? Just say it backwards. 1/2 of 4 is 2. So it gives us 2x plus 2. And you're finished. Number 6. The transformation is vertical shrink. Factor 1/3. It's okay, vertical. Is the vertical changing my x's or my y's? Vertical change is a y change. So can I expect that on the inside or the outside? Outside, okay. Well, if it's outside, then I can safely write this f of x, and I'll put something on the outside. It says shrink, so I need to know the operation. Is that add, subtract, negative sign, or multiply? Stretching and shrinking is always multiplication. Negative sign is reflection. Translations, which is shifting, is add and subtract. So it says shrink. So this is multiplication. Multiplications go in the front. The last thing I need to know is same or opposite for y changes. Same. That means I can just say that 1/3 because he said same. This means stick a 1/3 in front of your function. Just make sure that you capture the whole thing with a set of parentheses. And then distribute that 1/3 to both of the outside places. And then we call it g. And that is 1/3 in front of the parentheses, and 1/3 of 3 is 1. And that's finished. Remember, multiplication is always a stretch or a shrink. Negative sign is always a reflection. Adding and subtracting is always a shift. Always. Now the directions for the last, well, for number 7 at least, it says to use a graphing calculator to check your answer. I mean, you're welcome to do that, but there's absolutely no way you could show that in your homework. So even if the directions say to use a graphing calculator, first of all, I doubt many of you have a graphing calculator. Second of all, we don't use it on any of my tests. So, you can skip those directions. But if you want to make sure you did it right by using some kind of graphing technology, use Desmos.com. It's great. Desmos is awesome. So it says, let the graph of G be a translation 6 units down. Good morning, sir. Followed by a reflection in the x-axis of the graph of f of x equals absolute x. It's a lot of words. So what you got to do is you got to break it down. First thing that you should see is translation. That's where we start. And we have translation 6 units down. So then we use the script. If you're moving up and down, the question becomes, are you changing the x's or the y's? The y's, good. And if I'm changing my y's, is this going to be inside or outside? Great, so we know we're doing something to the outside. So for this one, I am going to do this in 2 different steps, if you guys are okay with it. I'm going to do it in 2 different steps. Outside. It says translate, that means shift. I need to know the operation. If I'm shifting, am I using add, subtract, negative, or multiply? Add and subtract. So you guys have already told me it's outside, so I know I'm going to be adding or subtracting something on the right side, because it's outside. Since it's outside, is it same or opposite? Same. Outside changes always do the same thing we expect. So if it says down 6, what would I be putting after my f of x? Negative 6 or minus 6. I heard both answers. They mean the same thing. Boom, there it is. We're going to do that first because we were told to do that one first because it says followed by a reflection over the x-axis. So let's just do this one. Let's do it in 2 steps. So whatever f of x was, which was just the absolute value of x, your job was to subtract 6 from it. Oh, yeah, that's it. Okay, that part's done. Scooby-Doo. I just need more space. Don't worry, I'll scroll back up. I'm not going to call this G yet because it's not G until we've done both things. So I'll just do this. Change it to black, showing you that it has now been altered. But at this point, I want to read what else I was asked to do. At this point, I was asked to do a reflection over the x-axis. So reflection over the x-axis. If I'm here and I reflect over the x-axis, does this thing move to the left or does it move down? Down. Well, if I'm moving up and down, am I changing my x's or my y's? The y's are changing. So if that's a y change, is it inside or outside? Outside. I expect something to be happening on the outside, and since it's a reflection, what am I looking for on the outside? A negative. Looking for a negative on the outside. You have to capture the whole side, though. And I've been saying that since the beginning. Every time I put a minus sign on the left, didn't I say, technically I put a negative on the entire side, right? I said that a bunch of times. That's because I knew this was coming. You're putting a negative on the entire side. So if you put a negative on the entire side on the left with parentheses, you'd better do the same thing on the right. And it affects all of the outside stuff, which includes that minus 6 that you just put there. And that is why order matters. This is now G. We now have a negative sign in front of our absolute values. And that negative 6 has turned to a positive 6. I'm out of curiosity, and it's okay if no one can, I'm just wondering, is there a brave volunteer who can look at the equation of g of x and judging by just the equation, tell me what it looks like happened. Just the equation. Now, the words specifically said shift down 6, then reflect over the x-axis. But if you look at the equation, wondering what we think it says, Nick? Right. So which one would you, just by looking at this, which y change would you have done first? Well, the 6, yeah. Well, we have moved 6. It's not 5 or 7. It's still 6. But no, maybe I need it. Let me restate the question in a different way. Let me be more clear. Just by looking at the two transformations, because it has two transformations, if you just had to look at the equation, which of these two transformations would you have done first? The minus or the plus 6 is what I'm asking. You would have done the minus first. Now, this is the same question that I asked Nevaeh. Sorry, I just wasn't clear enough. You would have done the minus first, because it's not a subtraction, it's actually a multiplication. So if you had to describe, just by looking at g of x, let's say there was no directions, there were no words ever for this question, and I just said, hey, describe to me these two transformations, you would have said the negative sign first, and then you would have said the plus 6. So if you were trying to describe this, you would say reflect over the x, then go up 6. You see, when you do it in the reverse order, you could still get, when you do it, if you want to change the order, you can still get the same answer with a different set of transformations. It's like the rectangle that I drew a minute ago, where I went right and then down, or you could go down and then right. So you could either shift down 6 and then reflect that over the x-axis, or you could reflect over the x-axis, then shift up 6. You get the same result. Either way, you get that g of x. I was just curious if we could describe those. And then number 8 says write a function k. So we changed its name to k. Woohoo! So we're going to write a function k, whose graph is a horizontal stretch of f of x equals absolute x by a factor of 4. And then we're going to reflect that over the x-axis. And we'll just go ahead and do it in 2 different steps, because it gave it to us in 2 different steps. Horizontal stretch. So you see the words horizontal and stretch. And you ask yourself, as it says horizontal, is this you changing the x's or the y's? Horizontal, class? The horizon is horizontal. That's left and right. That's you changing the x's. If you're changing your x's, are you changing the inside or the outside? Inside. So we're just going to go ahead and write f of, and we're going to leave the parentheses open because we know we're going to do something in there. It says the word stretch. So what I need to know is, will this be an add, subtract, a negative, or a multiply? It's going to be a multiply. So I know there's going to be a number sitting in front of my x. Inside changes, same or opposite effect? Opposite. So if I said stretch factor 4, what number do I see in front of my x? 1/4. It's reciprocal. It's not the opposite number, it's the opposite effect. So we use the reciprocal number, 1/4. We're not going to multiply by 4, we're going to divide by 4. So let's go ahead and do that part first, just because it's a substitution and I want to really make sure that we're all substituting appropriately. What it tells you to do is everywhere you had an x, you pop a set of parentheses. Worry about if you needed it later on. Just get in the habit of doing it. Okay, well, there was just this. So we drop a 1/4 x in there, and we see that, yeah, that set of parentheses wasn't necessary. Okay, well, you know what? It's not like it hurt us to draw it. And then the last transformation said to reflect over the x-axis. So let me grab my axes. Handy dandy axes. So if I'm here and I reflect over the x-axis, do I move left or do I move down? Which one reflects over the x-axis? Down. X goes left and right. So if I'm moving up and down, am I changing my x's or my y's? When you go from up to down, you've changed your y's. So if you're changing your y's, are you going to be changing the inside or the outside? Outside. And since it's a reflection, what do I expect to see on the outside? A negative. Negative signs are always a reflection. I've captured the entire left. Watch me capture the entire right. You ready? Oh, okay, I'm done. Because there was only one thing over there, so that's it. And we've been told to call that K. So K of x is equal to negative absolute value 1/4 x. And that is it. What I'd like for us to do at this point is find space on something somewhere to write an example. Just find space somewhere that you can write something to have as an example just for yourself. Somewhere earlier in the notes, any place you just had a little square of empty paper, we're going to put an example on there. And I want to see if you guys can pull this off either alone, if you're sitting alone, or with the person that you're sitting with. Try to talk your way through to try to do this example. I'm going to go ahead and tell you that f of x is equal to 6 absolute value of 2x minus 1 plus 8. That feels good. I'm telling you that's what f of x is. And I want to know, what is g of x? So I'm going to say find g, I was going to write g of x. Find g of x if g is, and let's do some transformations. A vertical shrink of factor 1/2 followed by a shift left, I don't know, what feels good? 2 units. Then a reflection over the x-axis. I've given you 3 transformations. Can you find g of x after following those 3 transformations in the order that I gave them to you? If you can, you understand your transformations. At least you understand how to change an equation. Because changing a graph is different. Or looking from one graph to another and telling me what happened. Or looking from one set of points to another set of points and telling me what happened. All these things are different. But can you get me the new equation? That's what I want to know. And I'll give you just a couple minutes to do it. This way I can make sure that I get the whole thing done before you leave. So hopefully everybody's trying. So in the essence of time, I'm just going to go ahead and get through this one because I want to make sure that we see the answer before it's time to leave. The first transformation is a vertical shrink of factor 1/2. Well, I know that a vertical change is an outside change. And it says shrink, so I know there's a multiplication. And since it's vertical, I know, which means a change in the y's, I know that it has the same effect. So if it says factor 1/2, I'm going to put a 1/2 on the front. So that means I have to put a 1/2 on the front of my entire right side. So here's the 6, absolute, 2x, minus 1, plus 8. The 1/2 has to distribute to all of the outside stuff, so the 6 and the 8. So that 1/2 f of x is now 3 absolute 2x minus 1 plus 4. Then it says shift left 2. A left and right change is an X change. X changes always happen on the inside. A shift is always plus or minus, and since it is an inside change, it's opposite. So that left 2 will actually end up being X plus 2. Everywhere I had an X, I am going to open a set of parentheses, which means 2 parentheses minus 1. And I'm going to fill those parentheses with this X plus 2. Oh my goodness, the bell has rung, so we didn't get a chance to finish the question. What a shame. Well, that was the hardest part right there, making sure that you distributed that 2. And the last thing we would have done is distribute a negative sign across all the outside. All right, buddy. Well, I'll see you tomorrow for whiteboard day. Have a good day.